What if a 40-kilometer journey through the mountains could shrink from 90 minutes on the road to just 10 minutes in the air? That would mean cutting travel time by almost 89%. And one Uttarakhand innovator is testing a machine built around exactly that idea. Called Hapida SKYNeX, the single-seat electric flying vehicle has already completed an early test flight in Almora. According to reports, Ravi Tamta travels a road distance of around 40 kilometers between his village and home, a journey that can take close to 90 minutes. The proposed flying route could potentially reduce that to around 10 to 15 minutes, saving roughly 75 to 80 minutes per trip. That changes the mathematics completely because 90 minutes is 1.5 hours, while 10 minutes is only 1/6 of that time. The reason is simple. Mountain roads cannot travel straight through hills, while an aircraft can take a much more direct route. That is the transportation problem this project is trying to attack. The machine is called HAPIDA SKYNeX, a single-seat electric flying vehicle developed under Hapida Sky by Ravi Tamta from Kaflakan village in Almora. The vehicle is described as being based on modified drone technology, using a compact multi-rotor arrangement rather than conventional car wheels and an engine. In simple terms, it is closer to a giant person-carrying drone than a traditional car with wings. The advantage of this layout is vertical takeoff, meaning the machine does not need a normal runway. That makes the concept especially interesting in mountainous areas where flat land can be difficult to find. The early flight test was conducted on open ground in Almora, with Tamta and his team evaluating the prototype while a person was on board. Videos of the demonstration later spread rapidly across social media, bringing the project national attention. The important number at this stage is 1 passenger, because the prototype is designed as a single-seater. There are no verified public figures yet for its flight speed, range, or duration. So the test proves that the machine can lift a person into the air, but it does not prove that it is ready for long-distance travel. That distinction is extremely important. Why drone technology? A drone stays airborne by producing enough thrust to overcome its weight, while different motors can be adjusted to control movement and stability. Scaling that system up for a human passenger creates a much harder engineering problem because every kilogram of structure, battery, and equipment needs additional lift. If the aircraft becomes heavier, more power is needed, which can require a larger battery, which adds even more weight. It becomes a complicated weight versus power equation. The single-seat design helps reduce that problem by limiting the payload to 1 person. That makes the current prototype a practical starting point for testing the basic flight system. The Hapida SkyNeX is a fully electric flying vehicle, following the global move toward eVTOL technology, using electric motors for vertical flight and short-distance travel. However, key figures such as battery capacity, speed, range, flight time, charging time, and payload have not been publicly confirmed, so stronger performance claims would be speculation. For now, the 40-kilometer target remains an intended use case, while independent testing will determine whether the prototype can eventually become practical transportation. Uttarakhand provides an unusual testing ground for this kind of technology because mountain geography can make road journeys much longer than the direct distance between 2 locations. A 40-kilometer road trip taking 90 minutes has an average travel speed of only around 27 kilometers per hour. A theoretical 40-kilometer trip completed in 10 minutes would require an average of 240 kilometers per hour, although there is no evidence that the current prototype can achieve that speed. The calculation simply shows why cutting across the air could dramatically reduce travel time. Instead of making roads faster, the concept tries to avoid the winding road altogether. A vehicle carrying a person needs far more than enough power to take off. It needs reliable flight controls, motors, batteries, structure, and emergency systems, because a failure in the air has very different consequences from a failure on a road. Weather creates another problem, particularly in mountainous areas where wind conditions can change quickly. Battery failure is also a major concern because the stored energy in an aircraft is much greater than in a small consumer drone. The current prototype is still at an early stage, so extensive testing would be required before regular passenger operations could even be considered. Flying is impressive, but landing safely every single time is where the serious engineering begins. The test flight attracted attention after videos of the aircraft appeared online, and Uttarakhand Chief Minister Pushkar Singh Dhami also shared the footage on X. That helped turn a local engineering experiment into a national talking point. At the same time, social media users raised questions about whether the machine was actually developed locally. Tamta has reportedly denied claims that the vehicle was imported from China and invited reporters to visit his manufacturing unit. Modern technology projects often use components from different suppliers. So the more useful question is what the team designed, modified, assembled, and tested themselves. The flying vehicle is part of Hapida Sky's wider innovation work, including earlier projects focused on everyday problems. Affordable motors, sensors, batteries, and electronics are helping smaller teams build advanced prototypes. Each prototype helps test ideas, find problems, and improve the next version. Is it really a flying car? Calling the Hapida SKYNeX. A flying car makes the headline easy to understand, but technically it is better described as a single-seat electric flying vehicle. A commercial flying car would need certification, maintenance systems, insurance, trained operators, or highly reliable autonomous controls and clearly defined flight routes. It would also need suitable places for takeoff and landing. A normal car can stop beside a road, while a flying vehicle cannot simply land wherever the driver feels like taking a tea break. The current prototype does not need to solve all those problems yet. Its immediate challenge is proving that the basic aircraft can fly reliably and safely. The most interesting figure remains the proposed 40-kilometer journey. At 90 minutes by road, the average journey speed works out to roughly 27 kilometers per hour. At 15 minutes in the air, the same 40 kilometers would require an average of around 160 kilometers per hour, while 10 minutes would require around 240 kilometers per hour. These are mathematical comparisons, not specifications for the Hapida SKYneX. They simply show how much performance would be required to deliver the claimed travel time advantage. The aircraft would also need enough battery energy to complete the journey with an appropriate safety reserve. Until real-world range and speed data become available, the 40-kilometer target remains a vision rather than a demonstrated capability. What happens next? The next step is more testing, with repeated flights checking the motors, controls, structure, battery, and stability in different conditions. Verified figures for speed, range, battery capacity, and flight time are still unavailable, so the prototype cannot yet be compared with commercial eVTOL aircraft. The first flight proves that the machine can carry a person into the air, but 10, 50, or hundreds of successful flights would be needed to understand its real reliability. If the vehicle ever moves toward passenger service, safety testing and regulatory approval will become just as important as making it fly. The project is still an experimental prototype, but its target is easy to understand. A roughly 40-kilometer journey that can take about 90 minutes by road could theoretically become much faster through the air. That means the current road journey averages around 27 kilometers per hour, while completing 40 kilometers in 15 minutes would require an average of about 160 kilometers per hour. Whether the Hapida SKYneX can eventually achieve anything close to that remains unknown, but its first flight has already put personal electric aviation on the map in Uttarakhand. If you enjoyed this video, don't forget to like, share, and subscribe for more content.